Hi, here we go again with episode number 10 of Controlix Developer. I'm Christian, hello and welcome. Like in all the previous sessions, we're dealing with the possibilities and features of Controlix automation from Bosch Rexroth. There's no big surprise today. I have a well-known guest with me. Welcome, Johannes. Who doesn't know him?
Who does not know me probably does not know you either, Christian.
You're right. Today we talk about a very special topic, which probably sounds a little bit like early Christmas to the developers from the field of industrial automation. But you have the honor to explain to us what today is all about.
Gladly. So first of all, I'm Johannes and a software developer at Bosch Rexroth. And if you already know this channel, you probably know that. And the topic of today, you can see it on my t-shirt. It's all about the programming language Python and what you can do with Python on Controlix automation, especially in the field of artificial intelligence. By the way, in this episode, you have the chance to win one of these t-shirts. Give this video a thumbs up and leave a comment to take part in the draw.
Let's start with my regular silly question. Why Python?
Okay, that question is not that silly. We compare different scripting languages, and one thing that definitely spoke for Python is accessibility. Python is really easy to learn.
And it's frequently taught at universities and colleges.
Accordingly, there's a very large community. Many projects and solutions can be found online, especially in the areas of artificial intelligence, robotics, and machine learning. For example, you can't simply realize the same project with C++ as with Python.
Okay. Did you have to learn Python completely new, or were you already professionals in it?
We are definitely not pros in it, but we can do a little bit. As I said, Python is really clear structured. For example, if you want to print out something, you can simply write print, not cout, not printf, just simple print. But of course, we also had to work out a few things, like how to bring a script instance to the control and how to adapt the script interpreter to our motion system, for example. And we still had to do a few things, especially to make it future-proof.
What does future-proof mean in this case?
Well, that we are also open for other scripting languages. But of course also that the integration fits for our customer and the motion system, for example, is easy to use.
Cool. But what interests me most is what can you do with Controlix automation in Python today, which you couldn't do before?
I was just waiting for that question. Today I prepared a small demo to show you an application of what you can do with Python on Controlix Core.
As always, I'm very excited.
We are currently in process to build an AI app that builds heavily on modules and algorithms that already exist. There's a lot of stuff that deals with repair and wear detection of components. And for today, I have an application with me that detects anomalies on an axis.
And how does it work?
I show you. We have here a Controlix Core with a simple PLC program. And to show this use case, we create a dashboard with Node-RED. Let's start the collection of the data. On the left side, we see first 4 extracted features, for example, the absolute energy. And on the right side, we see a 3D plot of the first 3 extracted features. We simply added another parameter to the telegram of the field bus, so that in each telegram is a current torque, for example.
So you collect and analyze torque data.
Quite right, but not only torque data, we extract and analyze several features. And if the extracted feature is unusual for the trained machine cycle, that indicates increased wear. And here we see the collection of the data. And if we go to the learning step 1, we combine all the extracted features. And in the learning step 2, we train the one-class support vector machine with the good data. And the learning step 3 is basically the anomaly detection. The red dots indicates anomalies. And if we now give a little impact on the drive, maybe Christian, you can do this quite short, we see anomalies. Now we see some red dots that indicates anomalies.
Okay, so this gives us the opportunity to detect wear and tear at a very early stage. The machine learns itself when maintenance is required.
Precisely. And to analyze and calculate this data to plan repair intervals, for example, we first take a look at a number of runs and use then certain algorithms to calculate when the whole thing reaches certain limits and, for example, a bearing needs to be replaced. That's called predictive maintenance.
Very impressive. So you programmed all this with already existing code snippets and algorithms?
Not quite, but much of it already exists.
And we have our own Python code blocks and libraries in the SDK.
Python is expected to be released in the SDK in March. The first example we will provide is for the ControlX data layer. And with this module, we want to achieve that you can use Python as fast as possible.
Okay. But today we have already a Python interpreter.
As always, perfect transition, Christian. As I already told you, Python is a scripting language. Unlike C++, it doesn't need to be compiled.
Exactly. This means it gets translated line by line and can directly run on our interpreter.
Right. Our Python interpreter is a tool to make Python scripts executable. It pushes the code directly to the motion system or the data layer, for example, without using the REST interface.
So without any delays.
And this also means that you can modify your code and make changes on your running application. You don't need to restart the control. This is perfect for pick-and-place applications. But we see this more in detail in the next episode with the topic of graphical programming, so stay tuned.
So we have an interpreter and we can make changes to the code while the machine is running.
And the machine operator can make these changes directly. Because Python is a clear and simple language, this should work without much effort.
That's right. And if this is still too complicated for you, our next episode on graphical programming is coming up on Christmas.
Exactly.
Okay, Python is a language that allows changes during the runtime of the machine. Traditionally, this was programmed in the PLC, which could hardly be changed on the factory floor. For example, to adapt to a new production sequence. So where's the trap? Is it really that easy?
Well, of course, with C++, for example, you can do a bit more in detail. But I don't use interpreter languages for applications where the millisecond or microsecond is important, but simply to be very flexible. Compared to proprietary systems with PLC programming, I don't see a trap at all. We are simply more flexible and easier to use.
Can you also implement hybrid solutions? So can you combine C++ and Python without any problem?
Of course. And the normal processes in a high-performance machine are programmed in C++, for example, or even in a classic PLC programming languages like structured text. But as you might already know, that's not my favorite way. For example, because it depends on real-time behavior. And the part that deal with artificial intelligence are outsourced to Python.
So the two big advantages of Python on ControlX automation is the ease of use and the access to already existing automation solutions.
That's right.
That was really impressive, as always, Johannes. So today we learned that Python is not only a clear and easy to learn language, it also perfectly suits to machine learning applications due to the already existing algorithms.
Yes, and with the predictive maintenance application, it was my intention to show you that we can even predict and take into account the wear and tear of a production setup.
Thank you, Johannes, for giving us once again such a great insight. Don't forget, you have the chance to win one of those shirts. Give us a thumb up and leave a comment to take part in the draw. Our next episode will be the last one, at least for the time being. There we will go one step further and we'll show you how easy it is to make program changes with the help of graphical programming, so-called low-code or no-code programming. I'm looking forward to it, and if you don't want to miss it, just click on the subscribe button. Until then, catch you on the next one to be 2 steps ahead.